we'll call this, how I say, step down. The other one was a step up. This is going to be a step down converter, right? Yeah, I forgot to say the other one will be having a gain function 1 over 1 minus d plus the turns ratio, right? So we can go back to, in this one here, we had that the output voltage will be 1 over 1 minus d times Vg, right? That's a straight boost gain. And then if you have n to 1 step down, it'll be times 1 over n is n to 1 through transformer, okay? But anyway, let's go back to here. You see what we've done there? Any idea what I can do to simplify this converter in different way? I eliminated, by eliminating this inductor, I replaced it with a diode. I eliminated step down function of the buck converter. You see that? But what happened if I eliminate this inductor? Then I'm going to essentially eliminate the eliminate step up function. Front end boost converter is removed. So let's do that. What if I now copy this and let's now replace this with what? We cannot replace it with the diode, right? Because they are only conducts in the direction. But we can put an active switch here, right? And this is D. Let's put this like a buck. This is D switch, and this is 1 minus D. So this is 2 out of phase switches. And we have this trick, right? How about now in this circuit, single diode changes direction, and this becomes positive, right? And this is, this converter with this here becomes, how you say, so you have a step down back D utility. So you, okay, so what we need to do here is put resonant inductance, right? So this is charged, and this is discharged in a resonant way, right? So that single little resonant inductor, which fix it in a boost, now fix it in a buck version. So this is charged, PWM, this is PWM inductor. So that inductor will have a current, which is in D prime, 1 minus D, goes down. So this inductor has on time, and then D and 1 minus D. So the 1 minus D, it is freewheeling diode, and during this part, it is charging. So this inductor is charging in a normal PWM. That's why I call this hybrid switching. You understand? Because this inductor still works during on time and off time like in a PWM inductor. But just like in a boost, this resonant inductor is now in series with the output inductor, and therefore, because it's small, again as before, it doesn't matter. And this resonance is happening in this loop. Okay. So you have this converter, which is now positive input and positive output, but it is having a resonance, and this discharge and charge is here, right? And then what we can do with this? Remember, I taught you this other trick, which is, again, we are doing step-by-step things. Aha, I have this switch here. I will use different color because it's too much of a red. What about if I now connect this switch to the output? Or it's better yet if I redraw this switch in this and remove this and redraw this switch. It was coming like this and connect it to the output. Sorry. The same 3 switch, magic, 2 transistors and 1 diode. And what is the magic? The PWM charge is storing energy in the PWM during on time, during D. you have a charge. But during 1 minus d interval, this capacitor, there is this loop, which I'll use red color. In this loop, resonant discharge, right?
Into
So
the load.
I didn't waste my effort of charging this capacitor, storing energy. I'm now changing it just by changing the bottom. And is this any problem? Because this is step down converter. If this is a 12 volt to 1 volt for microprocessor or whatever, you know, is this any problem that now this transistor is sitting at 1 volt and it previously sitting at the ground? You can have a high side driver operating from 1 volt, right? Being sitting on a DC of 1 volt, so it's not a problem. So therefore, just change of connection really makes this converter operate like I say, twice efficiency, because this will bring as much charge that was wasted here, all the charge resonant, except it's a resonant discharge. You see, this is a PWM charge, bringing the power to the load. But when this diode is turned on, it does two things. It provides this inductor, it's a freewheeling diode discharging to the load, but this diode at the same time, with this switch capacitor carries a capacitor discharge current to the load. So you can say you have two things helping, right? You have transferring energy from input to output through inductive transfer, but also through capacitive transfer. And there is no internal loss. So that, and there has a 2 transistor and 1 diode. And has a little resonant inductor, which you know, makes everything happening. So that is what I call the hybrid switching. And what happens here? Can I make this now? Okay.
What is the ratio between current
Let me finish, Alex, let me finish the point first, okay? And then I'll entertain the question, okay? The point I'm making is now, how do we do isolation transformer?
Same way we've done it all along. Break up the cap and put the inductor right in the middle.
Exactly. Thank you very much. So we put a capacitor here, we put a capacitor here, and we put a transformer or magnetizing inductance right in the middle. Voila, his isolated version of it. Nothing else, just adding a AC transformer for a step down. And this transformer can use actually both steps.
Well, wait a second. No, we can't do that here because we got the second transistor across the top, the blue one.
That's right. That's right. So
we're not quite fully isolated yet.
You're right. So what we're going to do, because you have a problem because this capacitor is moving from ground to the output and you have to have isolation. So yes, you have this version, right? Okay. But when we talk about that, so that is basically isolation transformer as we discussed here.
Yep.
And then we can remove this. So it's fully isolated.
Yep.
You can change the dot connection to get positive, negative, whatever you want. But now I have another question. And that's my whole point of making this new converters and how it goes. You have, can we do what we did in the other one? This there is a charge and there is this discharge here, but also maybe we can do this. From this point, put the switch on the output, force switch, which is the same as this diode. And then secondary charge will have this way, but we'll have discharge this way. So you can have a force switch, adding one force switch. But the point I'm trying to make with this, each time I add one extra component, I have a reason why I'm doing it. You see what I'm saying? And not just making this, how I say, called boondoggle. Okay, so at this point, let's do this and save it.